Hello, I'm Sunbum Kim from HCI Lab at KAIST. This study was done with Sunggeun and Professor Geehyuk Lee. I'm glad to present my work in this conference. I'll introduce DiaQwerty query variants to better utilize the screen area of a round or square smartwatch. Smartwatch is the most popular wearable device. Nowadays, we can do many things we did on smartphones with a smartwatch. For example, you can receive a friend call and check your text message and check your email with a smartwatch. But just receiving a phone call and reading a message and email may be not enough. You might want to make a phone call, or you might want to send a text message with a smartwatch. In order that, you should be able to enter text with a smartwatch. In order that, and many researchers have introduced several ways of typing on a smartwatch, and many studies adapt query layout. This trend may be because users may not want to invest time in learning a new keyboard on a smartwatch. Therefore, immediate learnability is important for smartwatch text entry. But query layout is not suitable for smartwatch because it is wrong horizontally. Why is this a problem? That's because of the smartwatch form factor. Typically, smartwatches have a narrow form factor. Smartwatches are round or square or even vertically long square. Smartwatch already has a small screen size, and adopting query layout to smartwatches result in more small key size. Many researchers have suggested several ways to use query layout on smartwatch screen with these form factors. These are most famous research on smartwatch text entry. The Zoomboard can enlarge a certain portion of a keyboard, and user can touch an enlarged key. The SplitBoard has a larger keyboard than a smartwatch screen, and only half of the keyboard appears on the screen. And user can move the keyboard through the swipe gesture. On the swipe board, user can choose one of the 9 parts of the keyboard by the first swipe gesture and choose the letter by the second swipe gesture. These studies were able to increase the key size of the query layout, but made the user go through several steps to enter a single letter. And actually, there have been many studies that proposed an error correction or suggestion-based keyboard with query layout on a smartwatch, such as a watch writer. However, in this study, we focused on the environment without language model. We thought that these 2 points should be satisfied for the fast text entry on smartwatch. First, utilizing query layout, and the second, single touch for single letter. We thought that how can we increase the key size without increasing the number of input steps? And we got inspired by the previous gesture keyboard research. These layouts have a narrow form factor to be optimized for gesture keyboards. These layouts were designed to reduce the distance of hand movement or to reduce the ambiguity of gesture recognition. As a result, these layouts have a narrow form factor. We thought that this interlaced layout would be useful for smartwatches. So we designed the interlaced diamond-shaped query layout with minor modifications. We adjusted the positions of P and L to make more narrow layout. It might make user more confused, but we can increase the key size by 10% more. We named this layout DiaQwerty and designed 2 versions of DiaQwerty for the 2 most popular smartwatch form factors. One is a circle and the other one is a square. And we determined the size of the DiaQwerty to be used in the experiments as follows. These sizes are based on commercial product. The 33mm is the most typical size for round smartwatch, and the 24mm by 30mm is the size of the Apple Watch screen. We choose this size to verify DiaQwerty's practical performance in the real world. As a result, we experimented with a relatively large round smartwatch and a relatively small scale smartwatch. In a round smartwatch, DiaQwerty could have a 35% larger key than QWERTY in terms of key width. And in a scale smartwatch, DiaQwerty could have a 43% larger key than QWERTY. We were able to successfully increase the key size, but its better performance is not guaranteed, because people will take more time to find the keys on DiaQwerty. We conducted a user study to evaluate the performance of DiaQwerty. We compared DiaQwerty with QWERTY and SplitBoard. QWERTY was chosen as the baseline, and SplitBoard was chosen because it is the best performance keyboard among non-predictive keyboards that require no additional sensors. We implemented each keyboard in two form factors, round and scale. All keyboards are implemented in the same smartwatch as Avain. For the scale layout, we used the scale space of the round smartwatch. Upper both ends are invisible, but we thought that keyboard performance will not be affected. We conducted two experiments on each form factor. And this is demo video. This is a QWERTY on round smartwatch. And this is the SplitBoard on a round smartwatch. And this is a DiaQwerty on round smartwatch. And these are scale versions. In experiment 1, we experimented with a round smartwatch, and there were 18 participants, and the keyboards were implemented in the LG Watch Avain. And participants complete 3 sessions with each keyboard, and each session comprised 5 blocks, and each block comprised 5 bridges. Participants sat in a chair and performed the task in a relaxed posture. This shows the key size of each keyboard, and the key figure on the right represents relative size. And QWERTY is 3.1 mm by 5 mm, and SplitBoard is 5 mm by 5 mm, and DiaQwerty is 4.2 mm by 4.2 mm. We measured WPM, words per minute, and UER on corrected error rates, and CER, corrected error rates, as the metrics in the experiments. And we conducted subjective survey about perceived speed and perceived accuracy, comfort, and preference using 7-point Likert scale questions. This is our result of experiment 1. In the final block, QWERTY, SplitBoard, and DiaQwerty reached about 26 WPM, 19 WPM, and 25 WPM respectively. Compared to previous studies, the speed of QWERTY was very fast, and the speed of SplitBoard was slightly faster than in previous studies. The result of repeated mesh ANOVA showed that the main impact of keyboard was significant. And the result of post-hoc tests showed that QWERTY and DiaQwerty were significantly faster than SplitBoard, and the difference between QWERTY and DiaQwerty was not significant. This is the result of error rate, and the solid line indicates the corrected error rate, and the dotted line indicates the uncorrected error rate. And the average corrected error rate across all blocks of each keyboard, QWERTY, SplitBoard, and DiaQwerty, are about 8%, and 5%, and 4% respectively. Like the result of speed, QWERTY was very accurate compared to previous studies. The result of repeated measure analysis showed that the main impact of keyboard was significant. And post-hoc tests showed that QWERTY is the most inaccurate and DiaQwerty is more accurate than SplitBoard. SplitBoard is more accurate than DiaQwerty. Uncorrected error rate were less than and uncorrected error rate was less than 1% in most of blocks for each keyboard, and the difference between the keyboards were not significant. This is our subjective survey result. We conducted Friedman test, and test results revealed that there were significant difference in perceived accuracy and preference. Result of post-hoc test showed that QWERTY was perceived to be the most inaccurate and DiaQwerty was the most preferred. Next, we conducted experiment 2 on simulated scale smartwatch. And there were 18 participants and none of them participated in experiment 1. And the experiment design and the procedure are same as experiment 1. This shows the key size of each keyboard. It is a little smaller than in experiment 1. This is a result of experiment 2. In the final block, QWERTY, SplitBoard, and DiaQwerty reached about 18 WPM, 18 WPM, and 21 WPM respectively. There was significant effect of keyboard, and DiaQwerty was the fastest, and the difference between QWERTY and SplitBoard was not significant. This is different result from experiment 1. This is the result of error rate. The average corrected error rate across all blocks of QWERTY, SplitBoard, and DiaQwerty were about 15%, 6%, and 7% respectively. There was significant main effect of keyboard, and QWERTY is the most inaccurate, and SplitBoard is the most accurate. As in experiment 1, uncorrected error rates were very low, and there were no significant difference between the keyboards. This is a subjective survey result. Friedman test showed that there was significant difference in perceived accuracy, comfort, and preference. SplitBoard was perceived to be the most accurate, and QWERTY was perceived to be the most inaccurate. And QWERTY was the most uncomfortable and the least preferred. The results of both experiments are different. QWERTY and DiaQwerty had similar performance in experiment 1. However, in experiment 2, DiaQwerty was significantly faster than QWERTY. We thought that this difference is due to the key size. In experiment 1, the error rate decreased by 4.31 percentage points, but in experiment 2, the error rate decreased by 7.81 percentage points. Participants used QWERTY well better than expected, so key size of QWERTY in experiment 1 seemed to be large enough to type correctly. In experiment 2, a key of QWERTY seemed to be small to type, so DiaQwerty was effective. We presented DiaQwerty, which is interested QWERTY layout, and DiaQwerty could be used well in the initial use by utilizing familiarity of QWERTY, and DiaQwerty was more effective on a small screen. And DiaQwerty was the most preferred in the experiment. And it's over. Thank you.
So we have time for several questions. Has anyone got any questions? So I have one to start things off. With the QWERTY layout, there are other techniques that can be kind of put on top of it, like swipe. Have you considered using swipe with that kind of diagonal pattern?
Sorry?
Have you considered swipe with DiaQwerty?
No, we considered that we only tap input to input text.
Okay. And I noticed also with some of the techniques you compare to, you do extra swipes or zoom in, at least in your related work. Have you considered using any other parts of the watch, like the buttons, to do anything?
버튼 work bezel.
Yeah. For instance, to zoom.
Sorry, we only consider using touch screen, and not consider using other button work bezel.
Okay. Yep.
Hi, I'm Leila from University of Waterloo. Thank you for your talk. So in your experiment one, the error rate of your proposed keyboard layout, DiaQwerty was the smallest, right? And so I was wondering, like, what is the reasoning behind that? Sorry, maybe you explained it, but I missed it. So at the beginning, when you were designing your experiment, you manipulated the position of the P and L
Yes.
keys, and then you thought that would create an unfamiliar position for those letters, and it may increase the error rate. But your experiment didn't show that. So why is that?
I beg your pardon.
So why was the error rate of DiaQwerty smallest in experiment 1? Why?
Why DiaQwerty is smaller than SplitBoard? Or why?
Yes. Yeah.
Even if it DiaQwerty then more large key size. I think DiaQwerty has a unfamiliar layout, so people may more consider to input key on a DiaQwerty. So DiaQwerty has a smallest error rate.
Okay. Yeah, and I think that's very interesting. Thank you.
Yeah.
I'll let the next speaker set up, but while that's happening, one final question. And so go ahead and let him set up, but I'll use this mic. So have you considered other shapes than the square rotated, like for instance a hexagon?
Hexagon? Hexagon is also can good shape, but if we use a hexagon that have a very long, vertically long scale, it may be a 1-to-1 aspect ratio. So it's so hard to use on smartwatch.